Hello everyone, this is VALI and today I'm going to describe and demonstrate about the application of finite automata in networking. So next we'll move on to contents of the presentation. So first off we start with introduction to automata theory and then comes types of automata. First comes the finite automata and then we go on to the linear bounded automata and then comes the push down automata are also known as PDA and then comes the Turing machine and then we move on to the finite automata and its uses and then we get to know basic logic about what is networking and then we see the uses of finite automata in networking and then finally we conclude the presentation with a conclusion. So introduction to automata. What is automata? The term automata is derived from the Greek word automata, which means self-acting. An automaton, that is the plural form of automata, is an abstract self-propelled computing device which follows a predetermined sequence of operations automatically. Automata enables scientists to understand how machines compute the functions and solve problems. The main motivation behind developing automata theory was to develop methods to describe, analyze, and analyze the dynamic behavior of discrete systems. Then we will see an example of automata. So finite automata are used to recognize patterns. An automation with a finite number of states is called a finite automata. It takes the string of symbol as input and changes its state accordingly. So when the desiring symbol is in the search is reached, then the transition occurs. At the time of transition, the automata can either move to the next state or stay in the same state. So here Q naught is the initial state, and then when input symbol 0 is given, it reaches stays in the same state, and when 1 is given as an input symbol, then it reaches to the next state. So similarly, in between we have an intermediate state. Here, when the input symbol is 1, stays in the same state. When the input symbol is 0, it goes to the next state, that is 1 0, which is the final state. And in the final state too, when the input symbol is 0, it reaches to the initial start state, and when the input symbol is 1, it goes to the intermediate state. So from the given automata, we can clearly say that this automata recognizes symbols of alternative characters, that is 1 0 and 1 0 or 0 1 0 1 in this fashion. So finite automata has two states, accept state or a reject state. When the input string is processed successfully, the automata reach its final state and then it will be accepted. How does the finite automata work? So here this is an example of an automata which we previously discussed already. Here from the Q naught is the initial state and 1 0 is the final state, and here we can see some of the symbols are accepted, and when they are accepted, like they are it goes to the next state, and the given finite automata accepts characters of alternate symbols, that is 1 0 1 0 or 0 1 0 1. So here no two same symbols are accepted together. So this is 0 0 is wrong or 1 1 is wrong. So next comes linear bounded automata. Uh, Here the computation is restricted to the constrained bounded area. So the input alphabet contains two special symbols which serve as left hand markers and right hand markers, which means the transitions neither move to the left of or end marker nor to the right of the right end marker of the tape. So here is a simple example of a linear bounded automata. Here you can see the left end marker represented as ML and the right end marker represented as MR. In the between we have the working space. So next comes up the push-down automata, also known as the PDA. In the theory of computation, a branch of theoretical computer science, a push-down automaton (PDA) is a type of automaton that employs a stack. Push-down automata are used in theories about what can be computed by machines. They are more capable than finite automata machines, but less capable than Turing machines. Deterministic push-down automata can recognize all deterministic context-free languages, while non-deterministic ones can recognize all context-free languages, with the former often used in parser design. So here we can see uh, for a PDA, we can recognize strings such as which are of infinite, but there is a logic behind them. That is 0 to the power n and 1 to the power n. So here we can see this type of strings are known as contextual language, and they can be recognized in a PDA. As here the logic behind this is the number of zeros are followed by an equal number of ones. This can be done in a PDA. Next comes up Turing machines. A Turing machine is a computational model like finite automata, push-down automata, which works on unrestricted grammar. The Turing machine is the most powerful computation model when compared with finite automata and push-down automata. There are various features of Turing machines. It has an external memory which remembers arbitrary long sequence of input. So here we can use Turing machines for infinite characters also. So the Turing machines has unlimited memory capability. The model has a facility by which the input at left or right on the tape can be read easily. The machine can produce a certain output based on its input. Sometimes it may be required that the same input has to be used to generate the output. So in this machine, the distinction between input and output has been removed. Thus, a common set of alphabets can be used for the Turing machine. So here we can see this is infinite input tape where there are blank symbols and different types of input symbols A, B, and here this triangle represents the tape head, and in between we have the finite control, and here a slash a comma r represents when this character is recognized we need to move to the right. So and here b comma slash b comma r represents when b is recognized in the state we need to move towards the right. Next up we have finite automata and its uses. uh, in the finite automata, they have applications in a wide range of fields, including computer science, mathematics, engineering, linguistics, and physics. Finite automata is mostly used for recognizing regular languages. Like one of the primary applications of finite automata is recognizing regular languages. Regular languages are a class of formal languages that can be defined using regular expressions, and they can be recognized by finite automata. This is useful in various fields, including compiler design, pattern recognition, and natural language processing. Next comes modeling computer systems. Finite automata are used to model computer systems such as network protocols, operating systems, and database systems. These models can help in analyzing the behavior of these systems, identifying potential issues, and developing strategies for improving the performance and capability of the machine. So now we get to know what is networking. So networking refers to the practice of connecting computing devices together in order to share resources and information. This can be accomplished through the use of hardware and software technologies that allow computers, servers, printers, and other devices to communicate with each other. So networking can take many forms, from simple local area networks, also known as the LANs, and that connect a few devices in small offices or homes, to complex wide area networks, also known as the WANs, that span multiple geographic locations and connect thousands of devices. Networking is an essential part of modern computing, as it enables individuals and organizations to share data, collaborate on projects, and access resources that may be located in remote locations. It also plays a critical role in enabling the internet and other global communication networks that are essential for modern society. So now we'll see the application of finite automata in networking. So, for protocol analysis, finite automata is widely used in protocol analysis, where it is used to model and analyze the communication protocols. Communication protocols specify the rules and formats of the messages that are exchanged between network devices. Finite automata is used to model these rules and formats to check if they can comply with the protocol specification. A finite automata can detect errors that such as the lost packets, duplicated packets, and out of sequence packets in the communication protocol. So here we can see there are two separate communication protocols for process 1 and process 2. So here in the process 1, it's for the client, and process 2 is for the server. So here there are some different states, such as where one contains the logged in information, the login and logout data, and one devices the wait time between the different types of states, and checking the credentials. If the credentials are matched, then the it reaches the final state where the user is logged in. And then for the server, uh, first comes the ideal state, and then from the ideal state, request is sent for the service, and if the login is authenticated, it reaches the final state, and the next task is performed. So networking can also be applied in the routing algorithms. So, for routing algorithms in networking, routing is the process of selecting the best path for the data package to travel from one network to another. For anything, there may be multiple paths, but we need to search the efficient path. So, it takes a minimal time. So, finite automata can be used to model, analyze the behavior of the routing algorithms. The finite automata can be designed to stimulate the behavior of routing algorithms, such as the Dijkstra algorithm, which is used for finding the shortest distance, or the Belford algorithm. The simulation can be used to test the efficiency and correctness of the algorithm. Next comes the network security. Finite automata is also used in network security, where it is used to detect and prevent security threats. The finite automata can be designed to detect the occurrence of specific sequences of packets that indicate an attack. For example, here we can see that there are so many states which are going to check the correctness of the password. So the user can log into the server. So if the password is correct, it goes to state wait one. But if the password is incorrect, it's not authenticated, and another state is reached and the session is ended. Finite automata can be designed to detect a sequence of packets that indicate a DOS, also known as the denial of service attack. Once the attack is detected, the finite automata take appropriate actions, such as blocking the IP address or alerting the system administrator. Here also, in this example, when the password is correct, it goes to a next authenticated state, where it goes to the next task. But when the password is wrong, the denial of service attack is interrupted. So the finite automata blocks the IP address and alerts the system. Uh, Finite automata can also be used in the intrusion detection. Detection is the process of identifying unauthorized access to a network. Finite automata can be used to model the behavior of normal network traffic and identify the deviations from the normal behavior. The FA can be designed to detect the specific patterns of network traffic that indicate an intrusion. For example, the finite automata can be designed to detect repeated login attempts from a single IP address, which would indicate a brute force attack. So, the intruder from the public network, when he tries to log in to the A state, so if there is any problem or if there are any long issues for multiple times, the automata machine detects it, and a warning is generated from the knowledge base. It is stored in the knowledge base, and next time when it repeats, it's again taken care of. So finally, the conclusion is that finite automata is a powerful tool in the analysis of various aspects of networking, including protocol analysis, routing algorithms, network security, and intrusion detection. The use of finite automata in these areas can help to improve the efficiency and security of networks. It is important to note that while finite automata is a theoretical concept, it has practical applications in the field of computer science, and including networks. These are the sources that help me to gather better information on this particular topic. Thank you.